Hello, mic testing. Anyway, let's solve some Leetcode problems, particularly the interview ones. Okay, मैं यहाँ हूँ. ये देखो remove duplicates from sorted array. तो I think I should speak in English, or should I? I'm actually trying to practice Python a bit. My goodness. This is a bit weird. This is a bit hard for me. I haven't learned this particular kind of. Oh, okay, I see. Listing. This is going to be a bit hard in easy in Java. Oh, okay, it's easy in Java. Fine. Let's try to do this only. Best time to buy and sell stock. Number 2. Okay, the mic is on. Okay, so best time to buy and sell stock. Okay. 7-1. I saw this problem somewhere else before. First of all, why is it 7? Why the output is 7? Let us check. Binary return the maximum profit you can achieve. Buy on day 2. Actually, I think, is there any graph of some sorts? Whiteboard online. Okay. Okay. देखो क्या हो रहा है, सबसे पहले ये समझो यहाँ पे क्या हो रहा है. ऑल्ट टैब, कंट्रोल टैब. थोड़ा सा एफिशिएंट होगा अगर मैं वाइट बोर्ड को यहाँ कर दूँ, बट एग्जैक्टली कर रहा हूँ. कंट्रोल टैब, या सो कंट्रोल शिफ्ट है. हाँ, 7 1 5 3 6 4 7 4. Okay, first of all, let us draw a graph. Okay, just a line. Okay, there is nothing. Okay, there's nothing like a. Okay, let's do a connection line again. I'm using this whiteboard for the first time. Okay. I think yes, it is over. Okay, cool. Now what they are trying to say is that, first of all, my stocks, how did we do, what we did using these, like those line graphs, we took 2 elements at a time. So let us just plot it, what they're trying to say. Let us see what they're trying to say. 1 2 3 4 5 6 7. Okay, 7 to 1. Okay, let us try to do this. 7 to 1. Okay, not actually very much approximate. The the intervals should be like this. The intervals should be like, in the x-axis the intervals should be constant. So I am messing it up a bit. Okay, fine, still fine. 71 control shift tab 715364 715 का था 1 2 3 4 and 5 okay 715 okay 2 3 3 L 6 okay, and then we are finally getting 4. Okay, so this is something like this is the stuff we are talking about. This is the thing we are talking about. Okay, so first our first data point is at 7, the second, the third, the fourth, the fifth, the sixth. Okay, so first of all in the 7, first of all from here to here there when it is the best time to buy a stock. So I have learned, well, I was watching a video of Vivek Bindra, and there it was the most popular video, and there I saw that, for example, the market is going on like this, and then it went down. My hand drawings are very bad here. So here when it is here, like when it is at a very low, when it is very low, then we should buy something, and when it is at a very at a margin, at some margin, at a certain margin, then we should sell it. Something like this is happening. Something like this is happening. To ensure the maximum profit for us, we need to check. We need to actually see what is being here. First of all, 1 rupees, and then look for example, let us think, assume that it is 1 7 1 what is this, 4, then 2, then 5 6, then 4 something, like this. What we are doing is that we are trying to, like, we are buying when it's low and selling when it's high, because to get maximum profit. For example, if we buy at 1 rupees, okay, if we are buying at 1 rupees, okay, now after some time it becomes 50 rupees. It is a very weird thing to say like that, but for example it becomes like 50 rupees, and then what we do, we just sell that. What we get? A 49 rupees of profit. Something like this is occurring. Like, track the lowest, track the high. What the problem is saying is that 715364. So 7. Why 7? Let us check. Buy on day 2. Okay. Buy on day 2 and sell on day 3. Profit 5 minus 1 equals to 4. Let us check. We need to check the consecutive elements. This is one of the weirdest things I ever thought of, but we need to check the consecutive elements. Like, what is the biggest consecutive jump we got? We need to check that only. Like, from this is actually 3. This is like this is actually 1, and this is actually our 4. Sorry, my handwriting is very bad here. So from 7 we got a dip. I don't know exact what the stock market terms are like. So we got a dip, and from 7 to 1, and then 2, then we got a huge jump to 4. Now we need to calculate those huge jumps, like those jumps in the array, like those ranges in the array, like those difference between two consecutive entities in the array. Do you understand? Exactly. This is in negative. We will not calculate this. We will omit this. This part I am talking about. But after this, we immediately get another big jump. We need to calculate these jumps. We need to calculate only these jumps, like this, 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 this. Oh no. We need to calculate stuff like this. Stuff is, I myself understood it right now. Okay, so let us write a code for this one. Beautiful. It's going to be beautiful, I promise. Okay, int prices. So first of all, while we need to, for, we all know what's going to happen. Int I equals to 0, I is less than prices dot length minus 1. Why am I doing it? Why am I doing it? Understand why am I doing it. First of all, we will I will only go till this. Our I, our favorite variable I, will only grow from 0 to this. 0, 1, 2, 3, 4. There are 6 elements, and it will not go till 5, the fifth index, as it should go if it is starting from 0. It will just go till the 4th element, because if we go here, then what is there to check with this? Where is the range? Let me just do it. Where is the range? Where is the range? Where is the range? Where is the range? We don't have any range. So what will we just do is that we will just try to go till here, so that we get the ranges only. We are calculating the ranges. There can be another approach that we will separately calculate the ranges and find those longest ranges, which will be negative. Just omit those, and we should, the things which will be positive, just add those. That can be done, but we are a bit mathematical here. Okay. So anyway, good. Now what we will do, ai minus 1, if a, no, not a, I think I should change it to a, because I may find it, I will use find and replace to change it later. Well, anyway, I can't use prices for a long time. Okay, I won't be using prices. ai plus 1, like we are the next element, if it is greater than, we will not do subtraction and stuff, we will just use greater than. ai, I'm just for my own convenience I'm doing it. Okay, if it is positive, if the different range is positive upwards, then we will calculate that. Is there in sum? Yes, we will sum function. No, not a sum, a variable. Let's keep it uncommented. Okay, s plus equals to, what will we do? I think we should keep it in a variable. Okay, int r equals to, int range equals to ai minus ai plus 1 minus ai. I think you all realized int range. Okay, I think I need to mute it. It is probably the best thing to do. If it is greater than 0, mind you, greater than 0, or it can be equals to 0, but it will make the process a lot tedious. Because why calculate the planes? Why calculate it? Why calculate? Like seriously, why calculate these stuff? We have no business calculating these. We have no business calculating stuff like this. We need to do something else. What are we going to do? S plus equals to range. We'll be doing like this. Okay. Okay. Now, what will we do? Let's see if it is accepted. If it does it get AC? Does it get AC? I have no idea, because oh my god, compiler. Oh ho ho ho. Mm. Mm. Yes. Compiler. Missing return statement. Oh yes. I forgot. That should be actually return statement. Let's check. Cool. Let's submit the code. It got a full AC. Wow, it's so great. Let me check what is happening here. Wow, your runtime bits 90.43%. Okay, my memory usage bits 34.30% of JavaScript bits. ठीक है. 34.3% is not that bad in case of memory. I don't know. I'm lower than average here, but my runtime, okay, that's an acceptable trade-off. Runtime 1 millisecond and memory usage 45%. I believe that the only thing which can surpass math, which can kill the competition between math and the runtime and the memory is the math thing. Do you understand? Understanding modular arithmetic is one of the paramount things a developer needs to know. A development needs to know congruences. A development needs to know modular arithmetic. You guys should learn it. But this is not related to this, but it can be used. The concept is very beautiful. You will like it. And even in fact, if you guys are learning cryptography, modular arithmetic, learning modular arithmetic is paramount. It's of paramount importance. Okay. You're on. Okay, fine. Let's do something else. Okay, AC. It went AC. All because I just drew this graph. You know what? Along with rubber duck debugging and stuff, there is also a thing called dry run. Dry run, what we do is that we either draw pictures like this, or like we use a copy to simulate the running. Actually, simulation of running through a copy. Like we literally do handwritten stuff. Like we literally write the variables and their values using dry runs. And in recursion, dry runs are sometimes very much essential. If you are using a copy, they are extremely essential, because you won't even understand if the variables are misnamed. Okay, so anyway, I think it could have been no, it could have been done more efficiently. Let's see. Okay, let's just turn off the full screen. I just want to see if anyone. Hello, Rehan. Okay. হচ্ছে ভাই 90.43% আর ভাই। ওকে, কুল। আর হচ্ছে ঠিক আছে, দাঁড়া আমি ছিলাম পরেরটা। এখানে কি হচ্ছে? টপ ইন্টারভিউ কোশ্চেনস। আমার তো রোজ আসার আমার ইচ্ছা আছে। I actually want to come here today here. remove duplicates from sorted array. Removing duplicates from sorted array is an easy task. Let's see if I can use it here. Do using C. Yes, pointers. I know pointers. Let's go. Let's go. Let's go. I think this needs no explanation. This does need no explanation. Let me just clear this board. What is that? New board or something like that. F9 F11. Let's good. I think it will be great. Okay, let's keep it like this. Let's keep it like this. Let's, if there is any option, okay, good, we will go downwards. Okay, fine. It's not supporting anyone to attach. Now duplicates in an array. How? In a sorted array. In an unsorted array it would have been difficult, but duplicates in a sorted array is very easy. Just see. What I'm trying to say is that, for example, stuff like this is happening. For example, like this, then what? Then something like I'm just using line graphs to represent arrays. For example, there is a let's assume this as the starting of the array, assume this as the ending of the array. Now 0 1 2 3 4 no, not exactly. Let's just, okay, it won't occur here. It's okay. 0 0 1 2 3 2 3 something like this. So just think of it like this. First of all, we are going from this. For example, there are elements 0 0 1 2 2 3 4 5 6. What do we need to find? We need to find the very, if there is any unique element which has not been seen in the previous stuff, in the previous elements, which is different from the previous element, the previous elements or the previous, or in a sorted array the previous element, then we can try to, if we see that the next element, like this is only a matter of 3 elements, we just need 3 elements. If we see that in the first the zero, for example, there is an array of 3 elements. In the first element, we will go to the first element and just see if the 0th element, is equal to the first element, and if the 0th element is not equal to the first element, and if the first element is not equal, if the 0th element is not equal to the first element. For example, 0 0 1, is the first element equal to the 0th element? Okay, fine. What can we do? Okay, so no. Okay, that is an edge case. We need to first check from the 0. It's the 0th element. Is it equal to the first element? If it is, then we will need to remove it. And if it is okay, it can be a bit hard, but it doesn't matter anymore. I will have to turn off the audio for a while. Okay, but I will keep on doing what I am doing. bypassing. That's weird. That something sounds like linked list actually. That can only be done using a W linked list, I guess. I actually don't know how to do this. Wait. What's this? I think okay, your function should return k equals 2 with the first two elements of numbers being 1 and 2 respectively. It does not matter what will be behind the return k, hence they are underscores. Oh, okay. I actually need to ignore it. If it is in a linked list way, that is better, but it is not in a linked list way. We are actually a bit in knee deep hot water. Okay, fine. Still fine. We will be fine. Enter array nums sorted in non-decreasing order. Remove the duplicates in place such that each unique element appears only once. The relative order of the elements should be kept the same. And the number of unique elements in numbers. How to ignore exactly? That can only be done using W linked list. I think it's just think about it. Change the array nums such that the first k of nums contain the unique elements in order present in nums initially. Return the remainder. Okay, return k. Okay. Wait, this is easy. Change the array nums. What they're saying is that 0, 1, 1, 2, 3, okay, change the array nums such as the first k elements of nums contain the unique elements in the order they were present in the nums initially. Change the array nums such as the first k elements of nums contain the unique elements in the order. The remaining elements of nums are not important, as well as the size of nums. The remaining elements are not at all important. We will just return k. This is amazing. So we are just returning this. Isn't that amazing? We can do this in an instant. How will we do this? This is easy. This is very easy. Let's just this is actually in the guise of compute the number of unique elements. Just this. We don't need to return anything else. This is an amazing sum. I is less than num size minus 1, or I think I should use I is equal to 1. Okay, fine. Num size num size minus 1, and then I plus plus. This is so beautiful. This is a beautiful sum. Now what we do? Equals to 1, I is less than num size minus less than equals to actually less than I plus plus. We go to from the first element to the last element. We will just bypass this. Let's check previous element. We will do nothing but check the previous element. Let's declare as they wanted int k equals to 0. Okay, fine. And now what did it? If nums I nums I is not equals to nums I minus 1. Okay, what will we do? We will just k plus plus. Okay, okay, okay. This is a beautiful sum. This is just a, let's see, because this can't be the answer. There should be some complexities. Oh, huh? Okay. Oh, I understood why. I understood why. 112. Okay. Num size. Will be num size. Okay, right? It is. It is only talking about one. Okay. Num psi. Num psi minus one. K plus plus. K plus plus. Whatever. One code result. This is, oh, how much is it running? 0 1 1, and then it is not going towards 3, it is going towards 2, 1 and 2, which is only running till 1 and 2, and we have 0 1 2. Okay, so it is not equal. But why? But why is it? What is happening is this: in the first element there is 0, and in the 0th element there is also 0. What are we doing? It is equal. It is equal. We need k plus plus. Run code. We need custom cases like 0 comma 0 comma 1. Let's check if this is running. Run code. 0 comma 0 comma 1. We are getting only 0. Why is it happening? First of all, let us try to use k equals to 0. I is less than num size I plus plus. Nums I equals to nums I minus 1. Okay. num size is equals to num size minus 1 will not be applicable. But if it is not equal, if it's not equal to the previous element, then we are trying to increase the element. Okay, that's good. But k equals to 0 for I equals to 1, I is less than num size, I plus num size not equals to num size minus 1. Why is it? I think I should even remove these brackets. These are just hindering my progress. For I equals to 1, I is less than num size, I plus 1. I think I should give it a give thousands and thousands of elements. 1, 2, let's see. Upon running code, we will get a lot of stuff. We will understand what is happening. 0, 0, 1, 2. What we are doing is that we are only getting 4 elements, but there is 5. So there is something 1 less. Exactly, 1 less. We are trying to. Let's have some errors anyway. We can't afford, but will need some errors. Okay, this is a runtime error. Fine, this is a runtime error. Okay, so what do we do? Why is it being 0, 0, 1, 2, 4, 4, 5, 0, 1, 2? This is actually oh, my test cases are being weird. That's why. Oh no. Okay. It's not. Let's try it out. Why 4 elements? Why 4 elements? Should have been 5 or 4. How many elements are actually unique here? Was 0, 1, 2, 3, no, 1, 2, 3, 4, 5. Just do it something like this, because the logic behind this is this. There will be at least one element which is unique. At least one element which is unique. If there is no element, there will be at least one element which is unique. Let's check. First of all, let's check the constraints. Nums.length is less than or equals to, or 1 is less than equals to nums.length. Like 1 can be equals to nums.length, but it cannot be 0. So it cannot be a null array, cannot be an empty array. So we will be right when we submit this code. Let's just try out 0, 0, 1, 2, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So why? Like why are we facing this? The function should return k equals to 5 with the first 5 elements are known. Why? Some things are. We can do this. I think we can do this. But what if I? Is it happening like this? 0 1 2 3 4. 0 1 2 3 4. Both of them are 5 element arrays. 0 1 2 3 4. I am starting from 0. Anyway, are you control tab? Okay. আর ঠিক আছে এবারে why forward? Why? I was muted. So what I just did was that I just shifted Now what are we doing? Let's see, let's check what are we doing. Let's examine. Now I is, first of all, what I have just done is that I've shifted the element checking totally. What I just did was that from 0 to the second last element. Okay, and then what I did was that I will be the last element, will be the index of the last element, because if it gets no confirmation, like it is actually num size -1, it is actually equal to the num size -1, which is less than num size, and which is less than num size, but it is not less than num size -1. Okay, which is just the last element of an array. For example, there is a length L, then we access its last element using L minus 1. That's simple. It is that simple. Now I is equal to the index of the last element, that is num size minus 1. Now what will we do with num size minus 1, or I actually? If AI is nums I is not equals to nums I minus 1. Okay, we will just do k plus plus once again. Oh, I understood why. I think we don't need it anymore. Yes. Let's check. Does my code run properly? Expected 1 2. What is this? 0 0 1 4. Why? I want to know why. Why is it becoming wrong again and again? We are not checking the last element. We are not checking the last element. I understood. Okay, I understood. I think it should have been plus. Let's go. Let's run the code. No, it's not working. Even now. We will be checking why. Because this is amazing. 112. Output became 112. We have started from 0. Okay. And less than num size minus 1. What are we doing? From 0, we are checking if the array index element of 1 is equal. If not equal, then plus plus. Okay, fine. There is one element. Okay. No, we should keep k equals to 0. Then only we can do anything. Now, why is it becoming like should keep this, and let's just, for the sake of discussion, this. Why there should be how are they doing it? We need to understand how they are doing it, because otherwise we won't be able to understand. Like, we won't be able to code this. Int nums input array, int expected nums expected answer with correct length, remove duplicate nums, calls your implementation. Okay, expected nums are length, num psi or expected num psi, if they are equal. Okay. How can this be hard? I'm just thinking. It's just so weird. What we need to do is that we need to we are back to the square one. Why? Why is it weird? Any guesses? What am I missing here? This was supposed to be an easy problem. What am I missing here? Is there anything I'm missing? Everything is fine. I think I need to first of all remove these so many comments. Just no, don't remove that. Control Y. Let's just remove this much. Okay. Now what will we do? Is that we'll just what is there? Nums equals to nums not equals to nums and minus 1. What are we doing wrong here? We are doing we can think of printing something. A compound statement is something you can do something like this. Actually it is when you are enclosing something in braces, it is considered as a single statement. Do you understand? Just a single statement. So why is a method called a black box? It is kind of a compound statement. A whole single statement it is felt like a single statement, but it is not a single statement, but it is a composition of statements. It is a compound statement. A method is also the the way to the things we say in a method in curly braces are actually a part of a single statement, are actually thought of as a single statement by the compiler. Like for example, for we have not given any brackets, and if there is a single statement, that is thought of as a single statement. That's why we won't need to give anything. So what was I thinking of? Printf. We are doing something weird. Printf percent what? %d, comma, what? I'm sorry. %d, comma, %d. %d. Nums I plus 1. Let's see for ourselves what they are. We are going to see it. Your std out. What do your std out क्या है? हमारे what is my std out here? 0 1 1 2 2 445. What? Ah, what is happening? Something sus. Let's see for yourself. What is happening here? What is happening here? 1 1. What is 1 1? 0 1 1. Like, what is this? Does this solve the problem? Obviously not. How does this not solve? How does this not solve the problem? 0. Wait. We are going to do something weird, something insane. 1 1. Ah, yes. Now we will get. Now we are cooking. 1 1 2 2 2 2. How is it becoming 2 2? This is weird. Shouldn't be 2 2. Not equals to there. Is there? It can't be. It can't be. No, seriously, it can't be. I understood. Run code. Ah, now I understand. 0 1 1. Still not understood. Slash n. Slash n is the best thing to do. Slash n is the best thing to write. 0 1 1 2 2 4 4 5. Logical enough. 0 1 1 2 2 4 4 5. Very logical. It is in fact extremely logical. But why is it becoming? Why is it showing me this? What are they wanting? This is what are they wanting? I understood. Pass by reference and pass by value. There are two stuff. There is stuff. It's going to be a bit hard. Let's do this. Anyway, let's do this. Not hard exactly, but still. Not equals to 1. K plus. Yes, obviously K plus. Not equals to 1 K plus. And if it is, then we know what to do. Then we obviously know what to do. We'll just have to look for deletion. I think we need to trade space for memory. We can do this. Should we? I have no idea. I don't know. Else just seeing anything? Once an element is incorporated, it simply needs to bypass its duplicates to move on to the next element. Bypass. How to bypass the duplicates? Bypass. This is. I am back to square one. This can be done by doubly linked lists. We can do something like selections. I have something. Wait, this is 1, 2, comma 2, comma 2, comma 2, comma 2, comma 2. Swapping. I think I can for swapping. How can you do that? How many hours am I live streaming, by the way? How many hours? Control tab. How many hours am I live streaming? 73 minutes ago. Fine, very much fine. But still, this problem is insane. Wow. Actually like it. Actually like this. Am I live streaming? I am not liking my own voice, by the way. Actually, using call by difference, we get to because we are using pointers. Now see, here is our contiguous elements of memory. What is contiguous? Contiguous is consecutive, basically. And these are basically consecutive or contiguous elements of memory. So what is happening here? We are now how can we bypass this? Like, is there any sort of, like, we are trying to skip this skipping thing to make it more memory efficient? We can try to use type diffs. We can use type diffs, but no, we can't use it. This is just simply weird. In Java, let us check these solutions. Let's check these solutions. Because I mean, no. Oh my goodness, I can't even access the premium content. Okay, I need to do it myself. Bypass its duplicates. Bypass. Wait, the word bypass is really weird, isn't it? Bypass. While int I equals to 0, while I is less than nums size minus 1, if wait a minute. How about keeping variables. Understand my logic? We will keep two variables, one which is actually carrying the array index, and one like something which is actually carrying the repeating stuff, and one which is this is the unique index for unique numbers, and index for duplicate index, the normal index. We can do something like this: int duplicate index and int normal index. Okay, this is going to be weird, but we are going to do something. There is a duplicate index, there is a normal index. If we see something that, if like we were doing earlier, num size is not equals to nums I minus 1. Let us keep I equals to 1. We will do the duplicate index, dupe index as 1. Okay, let us keep the dupe index as whatever I is. We will do that. Okay, this is already the initialization, by the way. Initialization. But what are we doing here? We are exactly doing, we are unique. It is actually a jumping. It is a dupe index. The dupe index variable is actually jumping like a frog to only the unique elements. Okay, and the normal index, what it does is that when it encounters something weird, okay, you are very much weird, please be here, let me just check it out. Oh yes, we also need something like int k equals to 0, index equals to I. Okay, we got it. Dupe index equals to I and what? K plus plus. Okay, it is beautiful. We got a unique element. What will we do after that? When we got a unique element, now we got a unique element. Normal, there will be 3 to 4 indexes running at once. Now see, 4 4 4 4, 16 bytes doesn't hurt us, but a whole array does hurt us, because especially when we have 3 into 10 to the power 12 into 10 to the power 4 bytes of bytes, that does hurt. But 16 bytes doesn't. 16 bytes don't. Okay, now we got a new element. Now what to do for duplicate elements? We will use an else clause. What will we do? Just have the normal. Okay, just have the normal be outside. Okay, which will be replaced later, and then we will go to if there is any duplicate, we will go there, go only there, go there only. It is just like bouncing a person, like how to explain this? Huh? Huh? There will be just the unique elements, just the unique elements, just the unique elements, just the unique elements. Div index equals to I, k plus plus. And now let us, this is unique. I think there should be I am actually using for this. Now it is jumping basically. It is jumping two unique elements. Now k plus plus, calculating the number of unique elements. Calculating the number of unique elements and find what we do. It is weird. It is indeed weird. Let me check the chat first. Nobody has chat. Okay. Concurrent viewers 0. Okay, fine. Chat rate 0, views 7. Okay, fine. How many watching now? Is it only me? Okay, fine. Okay. This is going to be very much good. We are very good. Now 16 bytes don't hurt, but 12 into 10 to the power 4 bytes does hurt. How many is that? How many is that? 12 MB. No, not 12 MB. 12 KB for a single array. 12 KB for a single array. That is unacceptable. But what? Unique index of I, elements, and k plus plus. Calculate the number of unique elements. Else normal equals to num size. Something is like, have the analogy of, like, let us analogize this with, for example, someone is jumping like this and someone is just walking until it is a duplicate element, my friend. It is a duplicate element, my friend. It is just jumping there. Okay, fine. It is just jumping there. Normal equals to num. No. We got it. We got something unique. If we do find something unique, then we will transpose. But till then, and see, actually it was, even if it is an unique element, for example 0 1 2 3 4, no, 0 0 1 2 3 4, for example, if there is even an unique element, if normal is even an unique element, after we give it a plus plus, even then it won't hurt actually. Like normal is there, it will only hurt to us if it is not equals to, come on, it will only hurt to us if it is equal. If it is not, okay, fine, we are getting there, okay, just jump there. Okay, we are going here. Okay. The unique element to the unique element to the next unique element. Normal will always be ahead of our unique index. So what will we do? Now see, unique index and normal. There are two entities here. Unique index and unique index and now when we see something like this happen, what we usually do is but sometimes normal unique index can be ahead of both of them can happen. If unique index is greater than normal, then we will just look is that is normal unique? That we need to ask ourselves. Is normal unique? That we do need to ask. It's just swapping it doesn't. This is what makes it the hard. This one makes it a very hard thing to do. This is just normal progress. This is unique number digits progress. Anyone here? Okay, we can do something like this. Now it's fine. We are still here, no worries. I'm just thinking about the problem. Let me just show you how much flows down. First of all, so what we were doing is that it was there non-decreasing. How to something is running while I is running, we will check if it is an unique index. Okay, a duplicate index goes there. Duplicate index goes in the duplicate stuff. We will do this. If there is any next unique, first of all, we got a new, and if there is a unique index, rightwards. If there is unique index, rightwards. Then we will replace it with this. Replace it with the normal. Replace the normal index value with the unique index value. And now what will we do is that we will go to the next. We will go to the next. If it is unique, okay. It's very weird to assert it. What to do? What can I do actually? Guys, Anyone here? Anyone? Okay, someone is here. Someone is here. Nah. Or is someone here? Guys, is someone here? Let me check. Nah. Nobody's here. Also, I have nobody. Like, I have no one watching like that. So it is weird, but I think I should. Yes. Let's just keep it like this. We can retrieve last submitted code. We can, if we just submit it, we can just retrieve the last submitted code. Okay, let's call it a day, guys. Let's call it a day. Bye. Goodbye, everyone. We will check this out the next day. It's going to be amazing. It's always going to be amazing. Trust me. Just take a breath, relax, and follow the coding sloth. The coding sloth is an amazing guy. I just thought of live streaming out of my own accord, but still, just I did what I wanted. I want to continue this. Let's see. Okay. We can solve stuff. So maybe we will probably solve this problem. I have no idea though. Let's see. Goodbye.